you will see that your unit circle, this is 0 degrees, and this is 90, and this is 180, and this is 270. I'm not going to call you on the exact location, but make sure it's where it needs to be, in the vicinity of where it needs to be. So I'm going to give you an exercise tomorrow when we get here, and it's going to be, you have to be within 10 degrees when you draw it. So if I'm going to, let's say I'm going to sketch the angle 132 degrees, okay? I start at 0, and then that's 90 degrees, and then I have to go 42 degrees further. Well, 45 degrees is right in the middle, so I would say it's a little bit left of the middle. And it has to be in here somewhere, 132 degrees. And you put an arrow on the end of the angle, and then you draw a wall where that arrow runs into, because that's 132 degrees. So if I want to graph 380 degrees, I have to go around a whole 360, and then I have to go 20 degrees further, and you would have the little arrow there, and that would be 380 degrees. When they give you a negative degree, what do you think you do? Let's say we have negative 68 degrees. If when we did a positive degree, we went counterclockwise, when you have a negative degree, you go clockwise. So 68 is going to be in there somewhere because this whole quadrant, every quadrant is 90 degrees. So it's going to be like 2/3 of the way plus a little bit more in that quadrant, okay? So just get it where it needs to be. Now guys, get your calculators out and add 360 to negative 68. So put negative 68 plus 360. And I'm going to be telling you to get the angle out of the woods sometimes, and that's what I'm telling you to do. Make it a positive angle. Go ahead and do that. So if it's 292 positive degrees, that means we're going to go this way, and there's 270, so you go a little bit further. Those two angles are called coterminal angles. Just like there might be 2 or 3 ways to get home from here. You either take Randolph, or you could take Providence, you could take whatever. But there are 2 ways to get home. Your end result is getting home. There are 2 ways to get to this angle right here, and that is going negative 68 degrees in a clockwise fashion, or positive 292 in a counterclockwise fashion. Everybody get that? So here, they want us to find the reference angle. The reference angle is the closest distance from the x-axis. Somebody's always going to find me the closest distance to the y-axis, and it's not. It's the x-axis. So in here, it would be how much would this angle right here measure, okay? So let's get 500 out of the woods. It might help us a little bit. So go ahead and get 500 out of the woods. Keep subtracting 360 until it's a number between 0 and 360. Go ahead. If this is 140 degrees, which is coterminal with 500, that means if this is 180, how far is it to go to get to 180? 40 degrees. That would be your reference angle. These are hard for some people, okay? They make silly mistakes on these, but they're not that hard. Remember, if an angle is in the second or third quadrant, you're going to find the closest distance to up here, to the left side of the x-axis. If they're in the first or fourth quadrant, you're going to find the closest distance to that part of the x-axis, okay? Reference angles are always positive. It's just a positive distance. How far did that angle end up from that x-axis fence? Everybody get that? So let's do another one. And this one is going to go like this. That's 300 negative 380 degrees. So when I get that out of the woods, I have negative 380. I get negative 20, right? And get it out of the woods again. You can look at it that way. So this is like negative 20 right there. How many degrees is that from the x-axis? Positive 20. So your reference angle equals 20 degrees. It's 20 degrees away from the x-axis. All right, so if I have an angle of 240 degrees, I'm going to take, if I want to find the radians, I'm going to take the degrees, because that's what I have, and multiply it by pi over 180. So be careful. When you're putting this in the calculator, don't put your pi in there. What is 240 over 180 times pi? Those bite the dust. 6 goes into each of those. 4/3 pi. You see it? Now look at your unit circle. Do you see the 4/3 pi right next to the 240?
Yeah.
If your homework, and I think it will, ask you for something on the unit circle, just grab it. Just answer the question.
So we don't have to show our work?
You don't have to show your work. All right? If it doesn't, which a lot of them won't, then you can show your work. So whenever you're converting to radians to degrees or degrees to radians, you will get that. Now if we go the other direction, 4/3 pi is radians, and I want to get to degree, then I have to multiply the radians by 180 over pi. Look what happens to the pi's. They bite the dust. And I get 4 times 180, which is 720, divided by 3, which is 240, I hope.